Hi everyone, this is a video solution for the OpenZeppelin Ethernaut challenge Gatekeeper One. So if we scroll down to the problem here, it says make it past the gatekeeper and register as an entrant to pass this level. So things that might help, remember what you've learned from the telephone and token levels, and you can learn more about the special function gas left in Solidity documentation, and you can click the links here. So looking at the code, so we see contract Gatekeeper One using safe math, address, entrant. So it looks like this is the thing that we'll need to overwrite with our own address. And we see the modifiers being declared here, and then the function here, enter, which takes a 8-byte gate key, and it has to go through these gate 1, gate 2, gate 3, which are basically modifiers. And the third modifier takes a gate key, which is 8 bytes in length. And that returns a boolean true if the function was able to run. And then the entrant is set to tx.origin, which is our address. So the first modifier, gate 1, if we look at that one, it says that require message.sender not equal to tx.origin. So this is basically what we saw in the previous challenges for telephone and token. So basically, to pass this requirement, all you have to do is to call this enter function through another smart contract, essentially. So that one should be easy to pass. This second modifier here, we've got this function here, gas left. So that's just the amount of gas that we've got left to run the function, essentially, and we're taking modulo 8191. Modulo is division and then the remainder. So division by 8. So we're taking the gas left, dividing it by 8191, and then finding the remainder. And so that has to be equal to, the remainder has to be 0, essentially. So that one might be a little bit more tricky to figure out. And then the third one here is just a whole bunch of conditions on the gate key. So we'll need to figure out how we can craft our gate key so that it passes all 3 of these requirements. So okay, first things first, let's get a new instance. This just opens up MetaMask. Yeah, and confirm. So that should have confirmed our transaction and we should have got a new instance. I'm just going to go up to View, Developer, JavaScript console. Just ignore everything up the top here. I've completed the level just before filming this video. So okay, so we've got the instance address right here. Okay, so let's go to our Remix IDE to solve this challenge. So here, I've just written a few things already just to speed things up. So we've got Pragma Solidity 0.8.0 using any version of Solidity above 0.8.0. And then I've defined a function, not a function, sorry, an interface, iGatekeeper One, which is essentially going to allow us to make a to call the enter function on our target smart contract. So I'll start a new contract, and the name of the contract will be attack. Let's create a new function, run. We're going to take in that key as a parameter. Actually, we don't need that at the moment. Let's just do that a bit later. So first of all, what we're going to do is to brute force through this the gas. There is another way you can solve this, the gate 2 section here, which is to essentially calculate all the gas that will be used in this function as it runs up to this point here. But we can also just brute force and find a gas value that works, because there's only 8,191 iterations that would have to do with guesses essentially. So let's just copy that number, and right here what we're going to do is, okay, so we'll need to create our contract here first. So let's create an Gatekeeper One target, and that's going to be a Gatekeeper One at address. If we go back to our address here, okay, so that's our target address here. It's giving me some errors. Oh yes, so let's just define this as an external. Got an error here. Yep, I don't need quotation marks here. Okay, so that should be good. So we've got our target now, and what we want to do is we want to essentially loop through different gas values to see which one works. So for unit 256i, and let's say we want to loop through, so we'd like to loop through this 8191 times, because that's the maximum amount of times that we'll be able to run essentially, and we're guaranteed to find a solution that will pass this second gate within 8191 tries, essentially different tries. And we'll also need to increment I. Okay, so now we've got I. Let's just define another variable here. Gas, and let's set that to some number that we know will definitely run this function. So let's just set it to maybe 10,000 will be fine. Yeah, 10,000, or let's just be safe and we'll just use 100,000. Okay. And so at the beginning, what we'll do is, okay, so let's add I to the gas. And then we will call our function target. So target dot enter, and we're going to give it a gas of gas, which is a variable here. And then let's just give it something random for the time being. It doesn't need to be correct because we're just trying to pass gate 2 at the beginning. So let's just pass it 0, 1. Okay. So now we've got that. So now what this will do is just loop through all the gas values and see which one works. And so this will return a different error value depending on which gate that it passes. So if the gas value is correct and it passes this requirement here, then we're going to be calling gate 3, and it's going to, well, it will most likely not pass these right here, these requirements. And so if you notice here, on gate 2, there is no like error message, whereas for gate 3 there are messages. So if we do a try and catch statement, which will essentially run this function, and if it reverts, then it's going to give us an error, and it's going to tell us what went wrong essentially. And so looking at that, we'll be able to figure out what gas value was past gate 2. So okay, so we're going to do a try. Okay, so we're going to try this function, and if that succeeds, well, it's not going to succeed probably, so let's just leave it like that. Catch. And this catch here, we're going to take memory, sorry, bytes memory, and let's call this reason why it failed. Okay, and here what we'll do is we want to find out basically what this reason is, and we also want to find out what the gas is. So if we get the correct reason, then we basically can print out the gas, so we know what gas value passes. So okay, so let's so just looking back at what I've done before, let's emit an event let's call this event say failed, and we're going to pass it the gas. Let's pass it reason first, reason and then gas. Okay, and then so up here we'll need to define a new event. Failed, and so this will be essentially, this is going to take in string reason and Union 256 gas. Okay, and then this one, oops, sorry. So this should be bytes, not string. Okay, so we've got that. And let's just double check everything. So we're catching, we're adding 1 to the gas, or we're adding I to the gas. You know what, let's plus equals to 1. So then it just keeps adding 1 to this for 8191 times. Okay. And this is compiling correctly, so let's try deploying this. Whoops, I need to select this one. Okay, so MetaMask pops up. Let's confirm. Okay. So we've got that. And so let's try running our function. Okay, so we're just waiting for it to mine now. Let me just move myself up. Okay. So that transaction has been mined, and so if we look at the details of that transaction, okay, scrolling down, and let's have a look at the logs section here. So in the logs, we can see reason and gas. And so, okay, for the first iteration that we did for this value of gas, it gave a reason of nothing, essentially. And so if we look back at our code, that's this. It's not passing this first, this gate 2, essentially. So basically, we're going to need to find where reason is not 0x, it's something else, because that would mean that we're over here somewhere. So let's go back. An easier way to do this would be, let's just go down and copy all of this, and now I'm just going to go over to Atom, my text editor, just copy everything in there, and then now I'm going to search for reason is 0x, and then so there should be one where it is not that quotation mark at the end. There should be one where it's either 0. Yeah, so we found, yeah, so have a look here. So reason is not 0x, nothing now. They've got some value. So this means that it's passing that gate 2. So this gas value right here will pass our gate 2. So let's copy that gas value and go back to our code. Okay, and so now let's set our gas to that value that we know will pass. Okay, so we're passing gate 2 now. Now we need to pass gate 3. So let's get rid of this. We don't need this anymore. Okay, so this gas value works. Now what we want to do is pass these checks here. So okay, so if we have a look at the first one here, this first require statement, we can see that we're looking at gate key, and it's passing it to a uint64. So this is bytes 8. 1 byte is 8 bits. So if you multiply 8 by 8, you've got 64 bits. And so a uint is uint64 also has 64 bits. And so this is essentially the bits of, so uint64 is just taking the bits of the gate key. uint32, we're passing it to uint32 function. That is chopping off, and you're only taking the first 32 bits of that. So let me just demonstrate that on Atom here. So let's get rid of all of this and make a new file. So just to demonstrate what is happening here. So if we imagine our, so looking at gate key, so it's an 8 bytes. So it will have, so 1 byte has 2 hexadecimals. So let's just say it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is what it will look like. The first section here is taking the first 32 bits, so half of it, right? So let's get 1, 2, 3, 4, 5, 6, 7, 8. So we're only interested in this second half here. So let me just space that out. So this is what we're interested in. And so the first requirement is saying that this has to equal, this last part has to equal this. So uint 64, so same thing here, uint 16, which is the first 16 bits, which will be 1, 2, 3, 4. So let's just, actually let's copy this. And now we're only interested in this section here, right? So if we want this and this to be equal, sorry, this, so this value and this value to be equal, well, 1, 2, 3, 4, this has to be 0, right? This has to be 0 for this to equal this. Because if this was not 0, if this was like 1, then this will be a bigger number than this. So these have to be 0 here. So this one, these must be 0. So okay, so our key is going to look something like right. And so okay, so we've got this part of our key. Now we need to figure out what the other parts are. Okay. So gate 3 part 1. So now let's have a look at part 2. So we're given that, so this is the same thing here, uint 32. So we're looking at the last, whoops. So we're looking at the last 4 bytes again, right here. We're looking at these, and it's saying that this doesn't equal this does not equal uint 64 gate key, which is the whole thing. So what this means is that, well, this section here cannot be all zeros, because if it was all zeros, then just this section would be equal to the whole thing. So from that we can conclude that to pass gate 3 part 2, we need to set any of these first 8 x values to be just anything other than 0. So let's just do 1, 2, 3. Let's just do that. So that should be that will pass gate 3 part 2. Now to pass gate 3 part 3, we're given that uint 32 so the first 2 bytes has to be tx.origin. So for me, my tx.origin is this, right? So let's take the first 2 bits, bytes, sorry, and go back to our atom. So that's what we need. So if we put this into our call of target dot enter, and let's pass it this value right here. So if we didn't make any mistakes, okay, so I'm not sure what was going on there, but I think I figured it out. So now I'm just going to put that bytes in as a parameter, and let's get rid of this old contract and deploy our new attack contract. And sorry, I forgot to put the gas here. So gas is going to be gas. So let me just deploy that contract again. Okay, so we've got our contract, and let me just paste in our key and run that. Okay, so that has mined now, and so now if this all went to plan, if we go back to our console and we do entrant, so this should be our address here, which it is. So now we've successfully set our entrant to tx.origin, which is our address here. So now I'm just going to go ahead and submit that instance. Just give it a moment. Yep, and there we go. So we've passed the level.